As expected, Constantine did a great job of describing sort of the intuition, the model, and the results. And so instead of getting buried in the details, I want to do a couple of things. I want to sort of kind of set the context for how I look at these results and then kind of piece the results together. And there's a set of them that I think I understand and are interesting, and there's a set that I'm not sure I quite understand, and those honestly might be equally interesting. So, if I think about sort of the traditional markets, sort of when I read the paper, it was about competition lending, which I think is an awesome topic. In fact, part of what brought me into finance is I like the economics, but finance is weird because we don't have physical goods, we have virtual goods, so our objectives and our constraints tend to be different. As I read through the paper's results, the lens through which I saw the author's results is this dichotomy of soft and hard information. That's not the language of the paper, which is perfectly okay, but it kind of sets the context for what they're doing. If I think about traditional lending markets, if I wanted a loan for my business or car, I'd walk down to the bank, I'd go see Yannelis. He knows my business, he knows where I live, how I drive, and based on that reputation, he would make the loan or not. It was a local loan, it was a personal loan, but it also means it's not at all scalable. There's a limit to how many loans he can make, and if you want to do different geographies, you got to have a different person. So the second type, this hard information, that's where the data collection and the data decision are no longer the same person or the same place. In fact, they may not actually be people, they can be automated. And what he was talking about to you is exactly that idea. Now that's no longer personal, it's no longer local, and it has large fixed costs. You got to collect the data, you got to design the model, but then the variable costs are low. In their model, it's zero, close enough, but that means you can run a massive number through it. And in our work, we were saying, what we would expect is this would make the world more competitive because you aren't constrained by your geography, you can invest everywhere. One way to view this paper is they're going to flip that the other way. So the ability to use this scalable technology, this hard information, is going to have an effect on competition. But what's intriguing is the effect depends on different markets, i.e. what the credit quality is. Traditional monopolistic competition. If you're a monopolist, you charge higher prices, and as a result, some people do not buy because the price is higher than their value. And that's socially destructive because there are trades that are beneficial that do not happen. This is different. It is true that they charge higher prices and the quantity's lower, but the ones they weed out are those bad types. So in this case, it's socially beneficial because you're not lending the ones that shouldn't be borrowing. So the results aren't the same, but more importantly, the intuition in some sense is flipped. So these are the results. If you have a more concentrated market, and they're going to describe this as HHI, so for benchmarks 0.25, since the firms are the same size, think of 4 firms. 1, we're going to 1. That markup increases. Now notice all the different credit qualities lie straight on the same line. So part of the genius of the paper is looking at how this affects different credit quality differentially. That doesn't happen in the markup. Where it happens is in the costs. And up here I have the quantity because I thought this was easier for me to understand, but Constantine in his presentation also put those default rates. So it's essentially the same idea. Now in the model, the measure of good types that always pay back is 1. The measure of bad types that do not pay back is Q. And so among the highest credit quality, there are very few bad types, and the more concentrated they get weeded out. Among the worst credit quality, there are quite a few, so they drop. That's the correlation they want. Now, a couple of things. It is different by credit quality, but notice the magnitudes. It is very large drop in quality among the worst credit qualities and very little among the others. Put those two together, and you get the interest rate numbers that we expect. The reason the interest rates move differentially with credit quality has nothing to do with the markup. That's exactly the same. It's all about the costs. And so when the costs drop a little and the markup goes up, interest rates rise. When the costs drop a lot and the market goes up exactly the same, that's when the interest rates fall. So the story in the empirical work is going to be described as a function of interest rates, But really, interest rates are markup as well as cost. And it's the cost that's going to drive that difference. Now, in the model, they have that cost as a function of the number of bad qualities, those Q. That's the part that I don't quite follow. I follow the math, but I don't follow the economics. Think about the way I described it. Think about the way Constantine described it. You build a big AI regression model. You collect a whole lot of data. You put the first, the 20th, the 500 through. That cost is effectively zero, and it wasn't clear to me why that cost would be different if you're doing it in the good quality or the low. The benefit would be different, but not exactly the quantity. Okay, let's start looking at the results. One of the awesome parts about this paper is the figures. The tables are great because they tell you the results, but the figures make it very clear. This is kind of the guts of the results. For the low quality below 600, the more concentrated it is, the lower the interest rates. That is a beautiful regression, like everything sits on the lines. Now these are 20 bins, so it's not quite that perfect, but notice it falls perfectly and it falls linearly. For the high quality, it goes the opposite direction. You get that positive coefficient. When you go from 20 to 10 firms, you go from 0.05 to 1 on the HHI, those interest rates increase, and then they flatten out. So although the coefficient's positive, it's not that same linear relation. In fact, it's the wrong sort of form from what I expected. I assume that as you add more and more firms, the market becomes more competitive, but at some point, there's no incremental effect. This is the opposite result. If you've got 10 banks, you're completely controlling it. Reducing it to 5 or 4, 1 has no effect. I was affecting the opposite direction. And you're going to see this in some of the regressions that I'll see in a little bit. Okay. Table 2 is the same thing we have for the earlier ones. And you see those coefficients. On the low credit, it's negative. On the high credit, it's positive. Look at column 2 to 3 or columns 5 to 6, and notice what happens to the R-squareds. What they're going to do is add county dummies, and the R-squareds are going to increase by 10 to 20x. The coefficient doesn't change. Why? Well, it's either an effect of cost, those are different delinquencies in the counties, or they're different markups. Later in table 4, when they do this for delinquencies, there's not much of an effect on the counties or on the cost, so this is a markup result, or I think it is. Well, except I've already got HHI in there. So there's something about these markets that's not changing cost, but changing markup over it, and that's the second piece that I didn't understand. Okay, I showed you the pictures where the magnitudes were large or small, so let's start to benchmark that. The average interest rate's about 7.8, the standard deviation is 1.3. The average HHI is 0.058, the standard deviation is 0.036. I was going to do -3 to +3 standard deviations, but the minimum is going to restrain me. If you go from the minimum to 3 standard deviations, among the low credit quality, you drop the interest rate by about 12%. Among the high quality, you increase it by about 24%. Even if you only go to 1 standard deviation, those magnitudes are huge. Huge relative to the data, huge relative to the other. Part of that may be the functional form. Remember in that previous figure, I said for the low quality it's linear, for the high quality it's nonlinear. These are logs. So this regression maps that right one, not the left one. And so I'm not sure if I can actually do the magnitudes all the way out. Perfect. They did 2 bins, but in the table, they break it out a lot more. And if you look above 600, when you do 600 by each of the 50s, the picture looks exactly the same. It's when you do the low quality is different. The 300 to 550 is exactly the same picture. It's that intermediate that's weird. It's going to increase and then it's going to decrease. And I think that's related to his table that he showed about 2/3 of the way in, where there's this effect, and that's the intermediate. It's partially about price. It's partially about cost. Before I go to the cost, I want to quickly look at the quantity numbers. So this is looking at the number of loans, or in the model, it's how many of the bad types do you throw out. And if you compare columns 1 and 2, it's exactly as it is in the model, in the sense in the low quality, you get a much larger effect, twice of it, than you do in the big. But when you start to break these, it looks a little bit odd. So when you break that bottom into two pieces, the coefficient actually drops by 50% in each of those. Now normally, if you've got a range and you break it into the lower and the higher part, the intercept will pick that up and it can flip the signs. Here you have the same level of HHI. If you look at the high credit quality, you have the same. And I drew a huge number of pictures, and I can't figure out a data structure that looks like this. One of the things I noticed, though, as he was presenting, the other thing I don't understand is look at the observation counts. So when you take that bottom bin, which has about 27,000, and you divide it into two subsets, it's 25,000 in one and 27,000 into the other. I think I'm missing something here. The last thing I want to talk about is the costs. Remember, the story that we're talking about is when you increase competition, the effect in the high and low quality are different. That's not a story about markup, it's a story about cost. So the guts of this is the cost, and this is the picture that kind of shows it. They're going to calculate delinquencies as cost, which I think is a first approximation is perfect. And what they find is as you increase competition, you're going to tend to have lower costs in the low and high, but the magnitudes are higher in the low quality, exactly as the model predicts. But look at the actual magnitudes. That probability of delinquency drops by about 200 basis points in the low quality, and it drops by about 2 to 3 basis points in the high quality. So relative, it's different. Go back and connect that to the interest rates. If the loss on these loans was 100%, then moving the delinquency about 200 basis points should move the interest rate by about 200 basis points. And the numbers we found from the regressions were much higher. The other thing that was interesting about this, and you saw the same thing in a couple of the other pictures, is these leverage points. So yes, when I run a regression, I get a negative coefficient, but there's one or two data points that my guess give me most of it. Take those out, it's going to be different. That's the first observation. The second is it's the same set. And you saw when he looked at HHI as a function of who buys it, it was that most concentrated 5% of the firms that do all the buying. So that means that we're digging in and figuring out who the bottom 5 and who the top 5 are. I thought it was, I thought it was a really interesting idea of seeing how this new technology is going to change competition. Part of the logic makes complete sense. The more monopolistic it is, you're going to raise prices and lower quantities. Part of it is new, but that's also the part I'm not fully following the logic and the empirics. Why is it those costs drop? One issue is that fixed cost is a function of the quality, and I still can't get my head around it. Two, they're fixing the number of banks. They're set at N. Why does the new technology not create entry? If you have a scalable technology where there's a fixed cost and very low variable, you should run that across all geographies. So that should reduce the competition. It's explicitly not in the model. It is somewhat in the empirical results. Remember, Constantine said that they're going to look at change in HHI due to bank mergers and defaults. Once you take those out, because their panel data says it has county and year dummies, there's other movement. And my guess is there's other things going on. Are the credit markets local or national? And in the paper, there's a little fuzziness between the cost side and the markup. If you build this model, I would have guessed you would build it nationally. You're not going to build one model for Omaha and another model for Salt Lake City. Yes, the data is going to be different. You might even have differences in dummies, but I would have assumed one model. Is the markup, the level of competition, is that a local or a national thing? In the old world where it was soft information and personal, it had to be local. This feels like much more of a national market. He didn't quite get to it in the presentation, but in the talk, you go into an auto dealership in your town, they're contracting out with a bank. That bank isn't necessarily local. I like the idea, I like the idea that more concentration leads to more moderate and weeding out socially beneficial, but it also seems like that technology is going to change competition and makes it much easier to scale and have a small number of lenders, like you sort of seen in credit cards and some of these other markets. Thank you.